Today you're going to complete Student Handout 2. To begin, I simply want you to complete the top half, not really half, I'd go with a fourth. And so pause the video. This is the title of our worksheet is Expanding and Factoring Expressions. And so use your understanding of the distributive property to work 1 through 3 and answer the question below. Pause the video. Take a moment and check, see how you did on simplifying the expressions. And now let's take a moment and look at the difference between the expression below. The x makes the 7 times x plus 2 an algebraic expression. When your expression contains a variable, we're often unable to follow the order of operations. So therefore, your only option is to use the distributive property, which this expression is completely simplified because no more possible operations can be performed. So what we're going to do currently is take just a moment and we'll look at the vocabulary below. So the distributive property allows the factor outside of the parentheses to be distributed to the terms inside the parentheses. So this is the factor on the outside of the parentheses, and as we have seen earlier, you are simply multiplying before you add, going from a multiplication to an addition problem. So we're going to practice that here. Each of the 4 members of the Robertson family ordered a drink, 2 slices of pizza, and an ice cream cone. So they have visual this problem, and now we're just simply going to write it algebraically. So 4 people ordered the exact same thing. They ordered a soda, they ordered 2 pizzas, and they ordered 1 cone. And as I distribute, using the factor on the outside of the parentheses to multiply each factor on the inside, I'm just going to remind you that, remember, each variable has a coefficient. That's the number in front of the variable, and when it is unseen, it's understood to be 1. So I'm going to add that just so we can note what we're multiplying. So 4 times 1 is 4, and you just bring the d down as a 2-factor term. 4 times 2 is 8. Bring the p into your final simplified answer. So we have 3 terms, all positive. Now we're going to look at a model, another way of visualizing the distributive property. Our model that we're going to look at is the area model. The area model works nice because it has your 2 factors. What is being shown is the length as 5, but the width is broken into 2 lengths. And if you add the 2 together, then they would represent the length of the entire rectangle. So to look at it in 2 parts, basically, this rectangle would be 5 times 3x, or that would be the same thing as 15x, because it's just factor, factor, factor. Multiply what you can, bring down the variable. This rectangle would simply be 5 times 2, length times width. That's going to give me 10. But together, the entire rectangle would have an area of 15x plus 10. So to look at that algebraically, we have 5, that's my length, times my width as an expression of 3x plus 2. 2 lengths represented as 1 length. And then you follow that distributive property, and you can see the visual and the math, they're going to be one and the same, because I'm multiplying 5 times 3x and 5 times 2. So that's going to give me my 15x plus, my 10. We have another model. This time you can see that the model is just representing our understanding of the distributive property, because we all know that you cannot have a length of -9. But if I'm looking simply at this first rectangle, length times width, I can see that it has an area of 7x. The second rectangle would have an area of 7 times -9, or -63. So together, the 2 rectangles would be 7x plus a -63 or -63. Now, if I want to look at that model to represent that distributive property, then these 2 lengths are thought of as 1. So I have a 7 by x plus 9. And if I'm going to find the area of that, move over a little bit, x plus -9, not 9, -9, then I can use the distributive property. And when I do, I should end up with that same area expression. And again, we have 7 times x, 7 times -9, and there's our 7x plus our -63. But because we're simplifying, and we want to make sure we perform all possible operations, we are able to rewrite that as a subtraction problem. And now you're done. Let's look at the back. On the back, you have a couple of problems that you're going to work together. And I'll begin. Follow the model. At this time, finish 6, 7, 8, and 9. Pause the video. Take a moment and check, see how you did. Pause the video to check. Now we're going to look at the next set of problems, which are distributing with more terms. And I'm not really distributing with more terms, but I'm going to distribute and I also have this other term added to our expression. We'll work one together. I am noting that I do have that -2. Remember, we want to make sure that we do see that as a -2, so you may rewrite that and begin with that add the opposite. I did say 6, not an 8. Sorry. Next, that distributive property would be done. Multiply. And as I finish, I'm going to sum my negative 12 and my positive 10, which is actually going to give me a negative 2. So we could rewrite that once again to minus 2. Pause the video, try 11 and 12. Take a moment and check. You may pause the video if you need to. Next, we're going to complete the factoring an expression. And expressions can be factored to remove the common factor. This is how we undo the distributive property. Determine the greatest common factor between the values. Remove the greatest common factor by dividing each term by it. So for example, what we're doing now is we're going from the addition, bouncing back to that multiplication, so the understanding of the equivalency between these two expressions. So the 6 and the 15 common factor is 3. 6 divided by 3 is 2. 15 divided by 3 is 5. So you factor out that common factor. And more models as a visual. I look at my two expressions, and I'm going to factor out the common factor. And then we're going to factor out the greatest common factor, which would be 4. I could use 2, but 4 is what we're asked for. And that would leave me with x, because see, 4 times x is 4x. Well, if I factor out the 4 from the 16, I'm left with 4, because 4 times 4 is 16. But if I want to look at the whole rectangle, then I'm going to see this length as one quantity. And you place those parentheses. Again, here we have our greatest common factor would be 6. If I factor 6 from 12, I'm left with 2. If I factor 6 from 18, I'm left with 3. 6 times 2 is 12. 3 times 6 is 18. If I visualize this as one length, then I'm going to visualize that expression as one number, adding the parentheses, and here I can see that multiplication that would lead me to my final area. Take just a moment, pause the video, and practice that factoring with the 13, 14, and 15. And check your answers.